Welcome to Section 6, Lesson 4. In the previous 3 lessons we learned 3 methods for solving linear systems: graphical from Lesson 1, substitution from Lesson 2, and elimination from Lesson 3. Each method works on every linear system, producing the same correct solution, but the methods differ in how much algebraic work they require for any given system. Today, we develop the decision rule for picking the most efficient method based on the coefficients in the equations. Choosing the right method does not affect correctness, but it can dramatically reduce the algebra burden, and recognizing the right method on each problem is the central craft skill of efficient system solving for the rest of the algebra course and into linear algebra. First idea on the board. The graphical method is best for visual intuition or when an approximate solution is acceptable. The method plots both lines on the coordinate plane and reads the intersection. It struggles with non-integer coordinates and is generally not used for exact solutions in practice, but it remains the best teaching tool for understanding the geometric picture of a system. Use it for understanding, not for production solving. Second idea. Substitution shines when one of the two equations has a variable with coefficient plus or minus 1. That variable can be solved for cleanly with no fractions, and the resulting expression substitutes into the other equation easily. Substitution also handles non-linear systems where a variable can be isolated, making it the more general of the two algebraic methods. Use substitution when you see a plus or minus 1 coefficient in either equation. Third idea. Elimination shines when both equations have integer coefficients greater than 1 and the coefficients align nicely or align easily through multiplication. The method avoids the fraction handling that substitution forces in those systems and is often the fastest path to the answer. Elimination also generalizes to many variable systems through the Gaussian elimination algorithm, which underpins all of linear algebra and computer-based system solving. Use elimination when both equations have integer coefficients greater than 1. Today's worked examples illustrate both algebraic choices on systems that favor each method. The decision among the 3 solving methods depends on the form of the equations. Each method works on every linear system, but each is most efficient on certain forms. Recognizing which method fits a given system saves algebraic work and reduces the chance of errors. The decision rule has 3 branches based on the coefficients of the variables. Branch 1. Graphical method. Use when you need a visual understanding of the system, when the problem explicitly asks for a graph, or when an approximate solution is acceptable. The method gives intuition about the geometry of the lines and their intersection, but is limited in precision. Avoid for exact answer requirements when the solution involves non-integer coordinates. Branch 2. Substitution method. Use when one of the 2 equations has a variable with coefficient plus 1 or minus 1. That variable can be solved for in a single step with no fractions, producing a clean expression for substitution into the other equation. Substitution is also the right choice when one equation already has a variable isolated, like x equals 2y minus 4, making step 1 of the substitution procedure free. Branch 3. Elimination method. Use when both equations have integer coefficients greater than 1 and the coefficients align directly or align easily through multiplication. The method avoids the fractions that substitution would introduce in those systems. Elimination is also the right choice when the 2 equations have one variable with the same or opposite coefficient already, allowing direct cancellation without preliminary multiplication. Combined decision rule. First, check for a plus or minus 1 coefficient in either equation. If found, substitution is usually fastest. If not, check whether the variable coefficients in the 2 equations align directly. If yes, elimination is fastest. If neither pattern matches, multiply equations to align coefficients and use elimination, or solve one equation for one variable producing a fractional expression and use substitution. The choice does not affect correctness, only efficiency, so develop the recognition habit through practice and apply the right method on every problem. Here is the first worked example. The system is x plus 3y equals 7 paired with 2x minus y equals 4. Choose the best method and solve. Notice that the first equation has x with coefficient plus 1, signaling substitution as the natural choice. Step 1. Apply the decision rule. The first equation has x with coefficient plus 1. Substitution is the recommended method because x can be isolated with no fractions. Solve the first equation for x equals 7 minus 3y. Step 2. Substitute the expression for x into the second equation. 2 times the quantity 7 minus 3y minus y equals 4. Distribute 14 minus 6 and minus y equals 4. Combine like terms 14 minus 7y equals 4. Step 3. Solve for y. Subtract 14 from both sides. Minus 7y equals minus 10. Divide by minus 7y equals 10 over 7. Use the flip sign rule on the inequality if applicable, but this is an equation, so just keep the sign. The fraction 10 over 7 is the y coordinate. Step 4. Back substitute y equals 10 over 7 into the expression x equals 7 minus 3y. X equals 7 minus 3 times 10 over 7 equals 7 minus 30 over 7 equals 49 over 7 minus 30 over 7 equals 19 over 7. The solution is x equals 19 sevenths and y equals 10 sevenths. Step 5. Verify in both originals. First equation 19 over 7 plus 3 times 10 over 7 equals 19 over 7 plus 30 over 7 equals 49 over 7 equals 7. Match. Second equation 2 times 19 over 7 minus 10 over 7 equals 38 over 7 minus 10 over 7 equals 28 over 7 equals 4. Match. So the solution is x equals 19 sevenths and y equals 10 sevenths. The big lesson from this example is that the system favored substitution because of the plus 1 coefficient on x in the first equation. Substitution produced a clean isolated expression and the rest of the algebra followed mechanically. The fractional answer is fine. Substitution handles fractions cleanly through the back, substitution, and verification steps. If we had used elimination on this system, we would have ended up multiplying the first equation by 2 and subtracting, which works but feels heavier than the substitution path that the plus 1 coefficient unlocked. Here is the second worked example. The system is 3x plus 2y equals 7 paired with 5x minus 2y equals 9. Choose the best method and solve. Notice that the y coefficients are plus 2 and minus 2, exactly opposite, signaling elimination as the natural choice via direct addition. Step 1. Apply the decision rule. Both equations have integer coefficients greater than 1, and the y coefficients are exactly opposite at plus 2 and minus 2. Elimination by direct addition will cancel the y variable in one step. Elimination is the recommended method. Left sides 3x plus 2y plus 5x minus 2y equals 8x. Right side 7 plus 9 equals 16. Combined equation 8x equals 16. Step 3. Solve for x. Divide both sides by 8x equals 2. Step 4. Back substitute x equals 2 into either original equation. Use the first 3 times 2 plus 2y equals 7. 6 plus 2y equals 7. Subtract 6 2y equals 1. Divide by 2y equals 1/2. Step 5. Verify in both originals. First equation 3 times 2 plus 2 times 1/2 equals 6 plus 1 equals 7. Match. Second equation 5 times 2 minus 2 times 1/2 equals 10 minus 1 equals 9. Match. Solution verified. So the solution is x equals 2 and y equals 1/2. The big lesson from this example is that the system favored elimination because the y coefficients were exactly opposite, allowing direct cancellation without any preliminary multiplication. Elimination produced the answer in one combination step plus a back substitution. If we had used substitution on this system, we would have needed to solve one equation for x or y producing a fraction expression, then substituted and dealt with fractions through the rest of the procedure. Elimination via direct addition was the cleaner path, and recognizing the opposite coefficient pattern was the key craft move. 3 mistakes that catch every algebra student during their first weeks of method choice work. Each one is a craft inefficiency rather than a wrong answer, but they add up to wasted time over many problems. First mistake: forcing one method on every system regardless of the equations. A student who has internalized substitution uses it on every problem, including systems where elimination would be twice as fast, or vice versa with elimination. Both methods are correct on every system, but the wasted algebra adds up over many problems on a test or a homework set. The fix is to develop the recognition habit through deliberate practice. Read the equations first, classify by coefficient pattern, then choose the matching method. Second mistake: missing a plus or minus 1 coefficient that signals substitution. A student looks at 3x plus y equals 5, sees the second equation as 4x minus 7y equals 2, and plunges into elimination because both equations have integer coefficients. The y in the first equation has coefficient plus 1, which makes substitution very clean. Solve y equals 5 minus 3x and substitute. The fix is to scan both equations for plus or minus 1 coefficients before any other analysis. Finding one usually means substitution is faster. Third mistake: ignoring opposite or equal coefficients across the two equations that signal direct elimination. A student sees 3x plus 2y equals 7 and 5x minus 2y equals 9 and goes to substitution because of habit, missing that the y coefficients plus 2 and minus 2 cancel directly when the equations are added. The fix is to scan both equations for matching or opposite coefficients on either variable. Finding such a pattern makes elimination the natural one-step move. Method choice efficiency matters most in time-constrained settings like standardized tests and contest math, where saving 30 seconds per problem across many problems adds up to substantial total time savings. 4 broad sectors below. On the essay, ACT, GRE, and most state algebra exams, the math sections impose time pressure that rewards efficient solving. A student who spends an extra 30 seconds per system solving the wrong way loses 6 or 7 minutes across a typical math section, time that could be spent on harder problems or on careful verification of all answers. The right method habit is therefore a high-leverage test prep skill, and the practice we do this week pays off directly on every standardized test you take. In ordinary homework, solving outside of time tests, the right method habit still matters because it reduces algebraic burden and the chance of computational errors. Substitution involves more arithmetic when fractions arise. Elimination involves more multiplication when coefficients need aligning. Picking the path with less arithmetic reduces the chance of slipping a sign or a digit. Across a homework set of 20 systems, the right method habit can save 20 to 30 minutes of pure work and prevent several errors. In computer software, the method choice is automated. Computer algebra systems and numerical solvers use Gaussian elimination as the default, which is the algorithmic generalization of the elimination method to many variable systems. The software does not need to choose a method because Gaussian elimination handles every linear system uniformly. Manual method choice is therefore a human-only craft skill, valuable for understanding and for time efficiency on tests, but not for software implementation. In engineering and applied math, real-world systems often have dozens or hundreds of variables, far beyond the 2-variable systems we cover in algebra. The matrix-based methods of linear algebra generalize elimination to those large systems through systematic row operations. The intuition you build today on choosing between substitution and the elimination on small systems carries over conceptually into the choice between different matrix factorization techniques in numerical linear algebra, where method choice matters enormously for computational efficiency on million-variable systems in scientific computing. 3 things to take with you from this lesson today. Method choice is a craft skill that does not affect correctness in any way, but can dramatically reduce the algebra burden on a system solving problem. And recognizing the right method on each problem is the central efficiency move for system solving for the rest of the algebra course and into all the harder math classes that follow it. First, 3 methods are available for solving linear systems: graphical, substitution, and elimination. All 3 produce the same correct solution on every linear system you can give them. They differ in how much algebraic work they require for any given system. The graphical method is best for visual intuition and approximate solutions. Substitution and elimination are the 2 algebraic methods that produce exact answers reliably regardless of the specific numerical values involved in the equations. Second, the decision rule for choosing the right method has 2 main branches based on the equations. If one of the 2 equations has a variable with coefficient plus or minus 1, substitution is usually the fastest method because that variable can be isolated cleanly with no fractions. If both equations have integer coefficients greater than 1 and the variable coefficients align directly across the 2 equations or align easily through a small multiplication step, elimination is usually the fastest method because it avoids the fraction handling that substitution forces. The graphical method is the third option for visual or approximate work. Third, the right method habit reduces algebra burden, reduces the chance of computational errors, and saves time on tests and homework problem sets. Forcing one method on every system is correct but slow when the system actually favors the other method. The habit develops through deliberate practice. Read both equations first, scan for plus or minus 1 coefficients and for matching or opposite coefficients across the equations, classify the system by these patterns, and apply the matching method. After a few dozen practice problems, the recognition becomes automatic and the right method is selected in under 5 seconds before any solving begins. The right method skill is one of the highest leverage test prep moves you can develop for any timed math exam because the time savings compound across all the system solving problems on the test. Beyond tests, the habit also pays off in homework and applied work because cleaner algebra reduces the chance of careless errors. Method choice is therefore both a speed skill and an accuracy skill, and the practice we do this week pays off across hundreds of system solving problems in the rest of the algebra course and beyond. Coming up next, the lesson called No Solution and Infinite Solutions, where we revisit the special cases when the algebraic methods produce contradictions or identities, indicating that the system has 0 or infinitely many solutions rather than a unique single solution. The contradiction or identity test is the algebraic counterpart to the parallel lines or coincident lines test from the geometric understanding of systems.